Okay, so let's solve this equation. All right, so as I told you, most of the time we're going to find a way to simplify what we have. And good question, what do we have for the moment? So we have this equation. So maybe you can take some time to write it again on your paper. We've got a function f of two variables, so x it's supposed to be a space dimension and t a time dimension. So typically we're going to get that x belongs to some interval. I don't know, maybe a, b, and t usually should be greater or equal to 0. But for the moment, let's just find what we get for the beginning. Well, the idea here is that we're going to use a substitution, a nice substitution. And we will see that it's going to simplify a lot the equation that we have, right? So that's good. Let's say we define our new variables u and v. U of xt is going to be x minus t, and v of xt is going to be x plus t, right? That is D'Alembert method. Right, so that we have, let's say that we have some new functions, so f of xt. I can say that it's going to be equivalent to if I had a function that depends on u and v, where u depend on xt, as we've just said, and v depend on xt, as we've just written it before. And so that's a function g of uv. And what I'm going to do is, starting with this equation that links the second order partial derivatives of f in each of its variables, we're going to see what it corresponds to in terms of g. Okay, so let's do that on the side. All right, so first maybe let us rewrite again the equation we want to solve. We have d2f over dx2 as a function of xt minus d2f over dt square as a function of xt is equal to 0. All right, or you can put one is equal to the other if you put it on the other side. Okay, anyway, often you will also see this equation written with a factor, with a constant c in front of the one of the second order partial derivatives, but well, this is something very simple to add later. All right, so let's do this. And I have this relation, so this is my equation, and I have this relation f of xt is equal to some function. That's what my substitution means. All right, with the u is equal to x minus t, and v is equal to x plus t. So let's do the differentiation. I need to find what are going to be the second order partial derivatives of f with respect to the second order partial derivatives of t. So let's begin with 1. Okay, so that's going to be the derivative according to x. So note that I'm using now a straight d on that right hand side because I'm not talking about directly the partial derivative of v according to its first or second variable, but I'm talking about whatever is going to be called x in this expression, and it's on both. It's going to appear in both partial derivatives. So now you are getting used to that. You know that you can apply the general very directly, even without thinking too much about that. I'm going to get du over dx times dg over du, so g, plus dv over dx times dg over dv. Okay? As we said, g being a function of u and v, it has two partial derivatives, one according to its first variable, which is usually called u, and one according to its second variable, which is called g, okay, which is called v. So these are the partial derivatives of u. So with the substitution that was given, du over dx is going to be 1 times dg over du dv over dx is also going to be 1 dg over dv. All right, and each of the partial derivatives of g are again functions of x and t. See what I'm getting at? So let's do the same thing for the second order partial derivative of f. Right? What do we have to do? We just have to differentiate again. Sorry, I'm going to use straight d because I'm applying the differentiation on that side of the equation, right? On this side of the equation, and which is again a function. I shouldn't have written that. A function of u and v, which are both depending on x and t. All right, so let's apply again a differentiation on what's preceding. So d over dx, sorry about this, d over dx of the previous expression, which is dg over du, u of xt, v of xt, plus dg over dv of u and v. Okay, all right. So what are we going to do? Of course, we're going just to apply chain rule again. So that's going to be du over dx of d2g over du square plus dv over dx times d over dv of d over du of g. Okay, I'm applying the chain rule. This has been addressing that first part. Okay, so I've got the whole second part to deal with again. So that's going to be du over dx times d over du of d over dv of g. Okay, so plus, sorry about this, plus dv over dx times, so what do we have now? d2g over dv squared. Okay, so you see what I did was just the d2 over du squared comes from when I differentiate this with respect to the u variable again. This is going to be the cross derivative when I'm still on that term, and when I'm working on this one here, this is all the terms it's giving me. All right, so let us make this a bit cleaner. We then have du over dx, again that's going to be 1, d2g over du square, dv over dx, that's again going to be 1. So basically all these derivatives are 1, but then I've got dv, d over dv, so that's the crossed d2g over dv du, which I will find again here. So I've got plus 2 times d2g over du dv. Okay, what's left? We have this one left, plus the second order derivative according to the v variable. Okay, so this is what the left-hand side of our equation, here, that one, looks like. See where I'm getting at? We should do the same thing for the right-hand side. So again, I propose that you pause and you are doing the same kinds of calculations we've just did, but for our function, oh, sorry about this, for our second order derivative dt squared. Okay, so which is going to be d over dt of the d over dt of g of u of xt, v of xt. That's it. Okay, that's what we have to calculate. So pause and do this calculation. Have you been able to do that? So very quickly, let's correct that. So let's do the first partial derivative. That's going to be du over dt times dg over du plus dv over dt times dg over dv. Okay, and so that's really d over dt of minus dg over du plus dg over dv. Okay, because du over dt from this, oh, sorry, from that, okay, that's just going to be minus 1, and dv, okay, so that's the 1, and the dv over dt, that's just going to be plus 1. Right, so let's do this again. We get, so the minus du over dt d2g over du minus du dv over dt times d2g dv du. Okay, that was for this first term has been treated here. And then let's do the second one. So this one, it's giving me, okay, plus. So I've got d2u over d2u over dt times d2g over du v plus, sorry, there shouldn't be a square here. But there was a u, plus dv over dt times d2g over dv squared, right? So that's for that second term gives you, sorry about this, that second term gives you that whole thing here. So let's write it a bit clearer with the calculations that, so that's going to be minus 1, that's going to be 1, that's going to be -1, and that's going to be 1. So finally, what we obtain from that is that d2u f over dt square is going to be, so let's see, this is going to be plus d2u over dg, sorry, that was, I had forgotten square here. So plus d2g over du square. Okay, that's this one. Then we have this is -1, this is -1, so -2 d2g. So these are the cross derivative, du dv. So assuming they are going to give you the same, well, we can exchange the order of differentiation applying the Schwarz theorem. And finally, I've got 1 time plus 1 time d2g over dv squared. Right, so now what do I have to do? I just have to sum these. And so sum, sorry about this, sum the result we had obtained for the partial derivative of the second order in x minus the result we obtained for the second order partial derivative in y. So let's write this. We have that d2f over dx square minus d2f over dt square is finally equal in terms of g. So partial derivative, when I'm differentiating twice according to u for d2f, will find a minus itself in the partial derivative according to t squared. So these terms are going to cancel, as well as these ones. Okay, these two terms are going to cancel. What is not going to cancel is this one and that one, because minus minus makes a plus. So what do we get in the end? In terms of g, this equation is actually equal to 4 times e to